Welcome to Python Basics with EJD. Still talking about object-oriented programming. In this video, we'll be talking about inheritance and code reuse in object-oriented programming. So here the goal is to introduce inheritance for hierarchical modeling in object-oriented programming, OOP, showing how code reuse improves maintainability and extensibility. So you can extend codes, you can maintain it, you can reuse it, and all that. That's one of the big advantages of object-oriented programming, right? So what are some basics of inheritance? Inheritance allows a child class to acquire. So you have class now, but you can have a child class and a parent class. So it allows the child class to acquire properties and behaviors from a parent class. So it's more like my father has a car, so I can, when I come of age, I can inherit my father's class and my father's car, right? So and it promotes code reuse and avoids duplication. So it's more like my father already has some leverage, so I don't have to I don't have to reinvent the wheel, that kind of thing. So the syntax is something like class, child, than parent. So the child is inheriting the parent. So of course, for the child to inherit the parent, then the parent class is already defined. So imagine that you have class parent and you have a function under the class parent, which is to greet, to say hello, my parent, right? Then you now have the class child into parent. So the child now inherits the parent. Then we pass here, right? But then the child inherits. So you can now call the child class. Normally you should call the parent class to get what the parent is doing. But since we have the class child inheriting the parent, you can now call the child class to get whatever the parent class would have given to you. So you have object equals child. So if you now say object greet, right? So because object is child, right? But the child has inherited his parent. So if you now say object greet, it gives you hello from parent because the child class has inherited the parent class. That's the basic idea as far as inheritance is concerned. Then we can use super, right? Super is used to call methods from the parent class. So if you want to call methods from the parent class, you can use super. So it is useful in constructors and overriding methods. So imagine you have class parent, okay? You have class parent, and it takes argument name. So you have self.name equals name. Then you now have class child, which inherits the parent. So then you, of course, the child now has its own attributes. So you have name for parent, right? Then for child, you now have name and age. So it means that the child inherits from parent and then adds something new to it. So it's more like, oh, maybe okay, I know of a family, Christian movie makers, right? And they have children, and those children have, because of the age of technology, right? They are using a lot of technology to revolutionize the whole drama thing. So they are adding, they inherit the name and then they add their own thing to it, right? They're using super now. So using super, you can just automatically extract whatever, because parents already had name, you didn't have to reinvent the name. So all you just need now is to add the age to it. So this actually called parent constructor. So this line 7, using this super, takes the name, because child also needs name, but the name is already with parents. So child only adds age and then everything is sweet. So you now have self.name for parents, but self.age for child, because that's what the child brings to the table, so to speak, right? So in this case now, if you say the child, okay, let me run that first, right? I'll use Alt and enter so you can create another cell automatically. So if you want an instance of that situation now, so you don't need to call the parent class directly, you just need to call the child, because now the name is called, so we have name already, and then this 10 now is what the child is bringing, because there's nothing like age with the parent. So you can now call this, you can now print C name, C age, and it gives you, say, the 10, right? So we have that like that. Okay, maybe we can do one more case, so where I say Alt Enter, and I have this, let's say child is now, what can I say here? Aboluwaji, let's say Aboluwaji, right? And that Aboluwaji is 23, right? So if you run this also, we have Aboluwaji 23. So let's talk about types of inheritance. So we can have single inheritance, multiple inheritance, multi-level inheritance, and hierarchical inheritance. So these are the types of inheritance like that. So talking about single inheritance, see what that looks like. So you have a class called animal, and you have a function under that class which the function is called speak. All right. Of course, you already know what self does. Self is always there. So, and then the job it's doing is to print animal speaks. But then you now have a class called dog, which is a child class, which inherits the parent class animal. So the dog class inherits everything animal, right? So but the dog class now in addition has define back self and then print woof, dog's back normally. In general, animal makes some sounds. Maybe I should even say animal makes, okay, well, animal speaks, that's fine. So in that case now, we now have, see what happens here, because we're talking about single inheritance. So I can run this using alt enter, put this now. So we now call the dog class because the dog is already inheriting the parent. So with the animal class, so we don't have to worry to call the animal class. So we use variable name this. We say D is dog, and then we now say D dot speak. You see D dot speak now, animal speaks. D dot back, animal. So it will just print woof, right? So the line 2 is going to give us animal speaks because the dog is giving us whatever is happening with because it has inherited the animal class. So in that case now, we just have animal speaks and then woof because d dot back is just referring to the dog directly. So it's more like a child operating at a multi-level. It can leverage on the parent's opportunities and leverage it on whatever it has. Then we have multiple inheritance. So how this goes. Now imagine we have class A. So you define method A self, and what that is doing is to print A. Then you have class B, define method B self, and that is to print B. And then you now define class C, which inherits both A and B, right? So class C inherits both A and B. And that is why we talk about multiple inheritance. So the child inherits, so it's more like if class A is mother, class B is child, and then class A is mother, father, class B is mother, and class C is child. So the child then automatically inherits whatever the two parents have. I mean, as expected, right? Just it's like gene. So the child inherits the genetics of both parents. So in this case now, we now have, okay, maybe I should just leave this the way it is. So we now have a variable C equals the C. Now, you don't have to go to parents again. You don't have to go to the parent. You can just call the child because the child has inherited both parents. So you can now say C dot method A, you know, and C dot method B to just give you, it will print A and B separately like that. So just like if I want to use it for the kind of thing I've been describing, right? Okay, let me use alternate enter in that case. So I don't have to stress about that. So here what I'm saying is class father, okay, class father, and then we say class father, and we know father has X father has XY chromosome, yes. Like if you do it in terms of genetic, and then we say print XY, and then class B. Well, I mean, just don't mind. I'm just trying to do something. So class B now, instead of B, I have class mother. All right, class mother. So mother has okay, okay. It's giving me all these things already. Yeah, let me just take it. I think it's fine. So father has XY chromosome while mother has XX chromosome. Yeah, that's what I mean to do. So XX chromosome. Then the class now, we now have class child with inheriting father and mother. And then we now have C equals child. And then this is XY and this is XX. So if you run this now, it just gives us, oh, okay. Okay, we still have all these ones. So we don't need all this. Don't need all this now. So I run this and then it just gives X, Y, X, X. Okay. So these are the things interacting to give birth to the child. That's basically what I'm trying to do there. So that's the idea of multiple inheritance. Then we talk about multi-level inheritance. Imagine we have a class called grandparents. So in this, for grandparent, now we define a function called greet. And what it does is hi from grandparent. And then we now have a class parent, we pass class child, we pass. Okay. So you see, grandparents, parents inherit grandparents, and child inherits parents. In essence, as child is inheriting parents, it's automatically inheriting the grandparent because the grandparent inherited the child. So if you now say CH is child and you say CH greet, it just says hi from grandparents. It's more like the grandparent is greeting the child like that, right? Yeah, so that goes. Then we have the final type of inheritance. You know, we have single inheritance, multiple inheritance, multi-level inheritance, and now hierarchical inheritance. Talking about hierarchical inheritance, we have class vehicle, for instance, and it has a function called drive, and then what it does is to print drive. So talking about hierarchical inheritance, now we now have class car, which inherits the vehicle, and then class bike, which also inherits the vehicle. So that's hierarchical, right? So you have vehicle. So in the case of father and mother, right, the child inherited both. In the case of hierarchical, the parent inherited the grandparent, and then the child inherits the parent. But in this case, now you have two children classes inheriting one parent, right? So the children class here are car and bike, inheriting vehicle, so that if you now say C is car, so B is bike, then you can say C dot drive, it will say driving. B dot drive, it will also say driving, because whether car or bike, you need to drive or move it like in some way. So you just have, so both at the end of the day, both of them are moving. So that's hierarchical. So two of them are inheriting one parent, so to speak. So then next we have the method resolution order, called MRO. So this defines the order in which methods are resolved in multiple inheritance, right? So if you use dot MRO to see resolution path, so it defines the order in which methods are resolved in multiple inheritance. So multiple inheritance is that case where a child inherited the two parents, right? So if you have class A pass, class B inheriting A, class C inheriting A, and then we have class D inheriting both B and C. So it also automatically means that this class D now that has inherited both B and C, and B and C have inherited A, it simply just means that class D, has everything A, B, and C actually have. So if we do print the DMRO, we just get this now. So we have class, which is D now. That's our focus. Then we have D, B, C, A, like that. So that's the method resolution order. So it defines the order in which methods are resolved in multiple inheritance. So from D to B, from B to C, and from C to A, like that. Because D is inheriting B and C. So we have D, B, C, then A, ultimately, like that. So yeah, so we have that. So let's move on to overriding methods. So child classes can redefine parent methods for custom behavior. So it's more like a child brings something, a child goes and says, we don't do that, we don't do that here. You've done that in your generation. This is how we want to do it going forward. For instance, you have the class animal and you have a function defined to speak, and we have print animal sound, right? Which is generic. But then we now have class dog, which inherits the animal class. And then here we define another speak for it. So same speak, but now instead of printing animal sound, we now print back. So it means that dog has overwritten animal sound by backing, right? So in this case, now you have D is dog, D dot speak, right? So D dot speak in this case now is just going to back instead of making animal sound. So if I want to do something close to this, let me do this. So imagine you have parents. Let's say you have parents, class parents, and then define let's say status. Status, you have status, and the status here is poverty, so to speak. So poverty by the parent, and then you now have class child, inheriting parent. So class child is inheriting parent, and then you now have, so same status now. Okay, same status. You now have okay, let me not say poverty. Okay, let's say status is middle class, so to speak. And then here, for the child now inheriting the parents, because the child has the leverage, we now have upper class. Or let me just say 1% of 1%. So that's 1% of 1% upper class, So the child leveraging what the parent had as, made it so much better. So we can now say, let's say we have, let's just say ST. ST is now, so the child, so ST is the child class. So that we now have ST dot status, okay? And it just says 1% of 1% upper class. So the child has changed the status. All right. So let's look at polymorphism in action. So the same method name can behave differently depending on the object. So imagine we have class cat. So class cat inheriting animal. So it's still referring to the same animal we have right here, right? So we have dog animal, right? But now we have class cat inheriting that animal class, and the definition speak self is now print male. So if you now have animals, dog and cat, so you can now say for A in animals, so you now print A dot speak, right? So if you pick dog, so you say dog dot speak, dog will give you woof, and cat will give you male, like that. So you have back and male easily. Okay, so that's polymorphism right there. So let's do a mini project talking about shape hierarchy. So that's some mathematical shapes. So first of all, we have a base class. That's like the original parent class. So you have class shape, which defines area. So, and it will raise no implemented error. Subclasses must implement this method. Okay. So this is not doing anything on its own. Then define perimeter self, raise non-implemented error. Subclasses must implement this method too. Then you now have derived class. You have a circle. So you define class circle, which inherits shape, right? What does shape supply, right? So shape is supplying the area, right? Shape is supplying area, but it is going to be implemented by each subclass, right? So you now have circle, you initialize, you need radius for this. You have self dot radius equals radius. Then, so in that case, now define area self. So for circle, right, you need pi r squared, pi times radius squared. So you say math dot pi, that's coming from pi is coming from math, and self dot radius, of course, this radius right here, raised power 2. So pi r squared, that's the radius, the area of a circle, and then the perimeter is 2 pi r. That's 2 times pi times radius, like this. Then you also have a rectangle, derived class for rectangle. So you have class rectangle, which inherits shape, so it inherits the function of shape. So we'll build a simple hierarchy inheritance overriding and polymorphism. So you can see all this circle and rectangle will be overriding the shape class. So you have rectangle, so which requires length and breadth. So you have self dot length is length, self dot width is width. So the area is length times breadth. So self dot length times self dot width. Then the perimeter is 2 times length plus breadth, like that. Then we also have the square class, which inherits rectangle. So we have class square inheriting rectangle. Okay, so we now have defined. So here we just need the side because it's square, right? So this now inherits whatever is coming. So we have self super dot init side, okay? Whatever side you got from a rectangle up here. Okay, in this case, now we just take the side, right? So this is bringing side into the story. And then for polymorphism in action, now we can now call the shapes. You say circle 5. So it means the circle is taking radius 5. The rectangle is taking, rectangle requires length and width. So the length is 4, the width is 6, and square is taking side 4. And for shapes in shapes, so it's some kind of iteration again. So it's some kind of iterable in this case now. So you take for shape in shapes. So you now print shape, class name, blah, blah, and you do all that. So it gives you all this information. Circle, area is 78.54 based on the area of circle, the radius. Perimeter is 31.42. Then for rectangle, area is 24.00 because 4 times 6 is 24. Then length plus breadth is 10 times 220. Square for area, you have 16. Then the perimeter is just 4 times 4, 16 also. So that's a simple project talking about shape hierarchy. And with this, we come to the end of this interesting video about inheritance. So we see the concept of inheritance in object-oriented programming, and it also bears a lot of resemblance with biological inheritance as we know it. So let me know how helpful this video is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have not subscribed already, you're missing a lot. So go ahead, subscribe to this channel and hit the notification bell so you can always get alerted each time a new video is released. You can take it a step further by clicking on join, and you have some special privileges right there. Ultimately, don't forget to like, share, comment so that more people can have access to the great content I have going on here till I come your way again. Keep doing Python right. Bye.